Hey, we're used to this system called Cartesian coordinates, which allows us to describe the position of any point in the plane by giving its distance from each of a pair of two perpendicular axes that we usually call x and y. Today we're going to look at a completely different system for doing the exact same thing, polar coordinates. We start with a point called the pole, and a ray emanating from that point called the polar axis. And then if we take any point in the plane, then its position in the plane can be uniquely described by its distance from the pole, which we usually call r, and the angle that it makes with the polar axis, which we usually call theta. So that the polar coordinates of this point are r theta. We need a few conventions to make this work. And the first is that if r is equal to 0, then we assume that the point is the pole regardless of the value of theta. The second is that we measure theta counterclockwise from the polar axis, just like we do in trigonometry. And the last is that negative r theta is just a way of writing r theta plus pi. And for the example that we've been looking at, I've sketched in the approximate location of negative r theta. Okay, I'll do a quick example and then you'll get a chance. Here I've established a pole and a polar axis, and I've marked off what one unit of length looks like. And suppose I want to plot the point r theta equals 1 pi over 6. Well, it would be about here, a distance of 1 from the pole, and an angle of pi over 6 from the polar axis. And just for fun, the point negative 1 pi over 6 would be right about where I've drawn it here. Okay, your turn. Draw yourself a pole and a polar axis, mark off a length of 1 unit on the polar axis, and see if you can't sketch the location of these points: 1 pi over 4, 1/2 pi over 4, negative 1/2 pi over 4, 1 negative pi over 4, and 1 9 pi over 4. So pause the video, sketch these points, and when you're ready, start it back up. 1 pi over 4 approximately over here, which would put 1/2 pi over 4 where I've drawn it here in red. And that would make negative 1/2 pi over 4 right around there. And 1 negative pi over 4 right around here, because negative pi over 4 is pi over 4 in the clockwise direction. And finally, 1 9 pi over 4 is the same point as 1 pi over 4, since 9 pi over 4 is pi over 4 plus 2 pi, or in other words, pi over 4 plus another full time around the circle. And this illustrates one key difference between polar coordinates and Cartesian or rectangular coordinates, and that is that in Cartesian coordinates, there's exactly one way to name each point, but in polar coordinates, there are many different names for any given point. And to be a little bit more precise about it, in polar coordinates, the point r theta is always equal to the point r theta plus 2n pi, where n is any integer. So not only are there many different ways to describe any point in polar coordinates, there are infinitely many different ways to describe a given point in polar coordinates. Okay, returning to the usual Cartesian or rectangular coordinate plane, it's often useful to be able to convert from polar coordinates to Cartesian coordinates and vice versa. And to help us consider this problem, it's useful to overlay a polar coordinate system onto the Cartesian coordinate system, which is easily done by simply setting the pole at the origin, 0, 0, and the polar axis to be the positive x-axis. Then if we consider an arbitrary point r theta in polar coordinates, then that point has some Cartesian coordinates x, y based on its distance from the x and y axes. And those distances x and y have a relation to the distance r and the measure of the angle theta through right triangle trigonometry, which tells us that the sine of theta is the opposite divided by the hypotenuse, and the side opposite the angle theta is the length y, and the hypotenuse has length r, so the sine of theta is y over r. And similarly, the cosine of theta is the adjacent divided by the hypotenuse, and the length of the adjacent side is x, and the length of the hypotenuse still r, and so the cosine of theta is x over r. And solving these two equations for x and y, we get that y is equal to r times the sine of theta, and x is equal to r times the cosine of theta, and these two equations tell us how to convert from polar coordinates to Cartesian coordinates. For example, suppose we want to convert the polar coordinate point 2 pi over 3 into rectangular or Cartesian coordinates. We know that x is equal to r times the cosine of theta, so that's 2 times the cosine of pi over 3, and the cosine of pi over 3 is a half, and so x is equal to 1. And similarly, y is equal to r times the sine of theta, so y is 2 times the sine of pi over 3, and the sine of pi over 3 is the square root of 3 over 2, and so y is equal to the square root of 3. And so we get that in Cartesian coordinates, the polar coordinate point 2 pi over 3 is the Cartesian coordinate point 1 square root of 3. It's occasionally useful to be able to go the other way to convert from Cartesian coordinates to polar coordinates, which is a little bit trickier because there are infinitely many ways to describe a point in polar coordinates. But we start with the same idea that the sine of theta is y over r and the cosine of theta is x over r. And this gives us that the tangent of theta is the sine of theta over the cosine of theta, which after you simplify, you get y over x. It also gives us that sine squared theta is y squared over r squared, and cosine squared theta is x squared over r squared. And adding these two equations together, we get that x squared over r squared plus y squared over r squared is equal to 1, because sine squared theta plus cosine squared theta is equal to 1. Multiplying by r squared, that gives us that x squared plus y squared is equal to r squared. And these two equations taken together, that x squared plus y squared is r squared, and that the tangent of theta is y over x, will allow us to convert from Cartesian coordinates to polar coordinates by solving for r and theta. And again, I'll point out that there's more than one answer that you can possibly get. In particular, notice that I didn't write r is the square root of x squared plus y squared. It's the positive or negative square root of x squared plus y squared. So there's two possible values for r there. And I didn't write that theta is the arctangent of y over x. The arctangent, we had to restrict the domain, so it has a limited range. Theta is any value whose tangent is y over x, and there are infinitely many possibilities. So slightly trickier going from Cartesian coordinates to polar coordinates. Okay, that was polar coordinates. There's a short homework on it just to make sure you're comfortable with the basics. So take a stab at that. Where we're heading with this is looking at the graphs of polar coordinate curves. I think you're going to find that pretty cool because it's pretty cool. All right, looking forward to seeing you. Bye.